Hello everyone and welcome to the lecture on kubectl rbac commands, role-based access control. And these commands include role, cluster role, role binding and cluster role binding. So first set alias k equal to kubectl. So first command is list roles in current namespace. So this list all roles in the current namespace, and this is the first command to check what rbac role exists before creating or modifying access permissions. So you may get output like this: so pod reader, my app role, deployment manager. So these are some of the roles which exist in the default namespace. Next, list roles across all namespaces. So k get roles followed by -a. So this list all roles across all namespaces in the cluster, and this is essential for understanding namespace scoped rbac permissions cluster wide and identifying which namespaces have custom roles defined. So the output may look something like this. You have namespace, then followed by the name, so name of the roles, and how long this has been created. So this is in days. So this was created 120 days back. So next is to describe a specific role. K describe role followed by the role name. This shows detailed information about a specific role, including the resource it grants access to and the verbs actions that are followed. This is critical for understanding what permissions a role actually provides before assigning it to users or service accounts. So this will give output like this: describe role. So this will have the role name, namespace, and any labels and any rules. So next is list role bindings in current namespace. So k get role bindings. So this will list all role bindings in the current or default namespace, showing which roles are bound to which users, groups, or service accounts. And this is essential for understanding who has what permissions in a namespace. And output will look something like this: name, role bindings. So this is the role binding and what role it is attached to and how long. So what is the age of this role binding? List role bindings across all namespaces. K get role binding followed by -a. This is just shortcut for -- all namespaces. So list all role bindings across all namespaces in the cluster, and this is useful for auditing which users or service accounts have permissions in different namespaces throughout the cluster. So the output will look something like this. You have the role bindings, and first we have namespace and what role it is attached to. So role binding, role, and what is how long, when was it created. So 150 days back, 15 days back, like that. So describe a specific role binding. So k describe role binding followed by the role binding name. So this shows detailed information about a role binding, including which role it references and which subjects, which can be users, groups, or service accounts, are bound to it. This is essential for troubleshooting why a user or service account does or does not have expected permissions. So the output may look like this: so name, namespace, and labels, annotation, and any role references. So this is attached to this particular pod reader role, and this is the role binding, right? And who can access this, like who it is attached to. So you have subjects. So service account, so in the default namespace, can use this role binding to get this role. Next we have list cluster roles. So k get cluster roles. So this will list all cluster roles in the cluster, including both system defined and custom roles. It shows the cluster wide roles that can grant permissions across all namespaces or to cluster scoped resources like nodes and persistent volumes. So output will look like this: all the names of the cluster role and their age. So this is cluster role. That's why we don't have any namespaces in the picture. So describe a specific cluster role. So k describe cluster role and followed by the cluster role. So as I talked about, we don't have namespace option because this is specific to this is applicable to the whole cluster. So it does not belong to any namespace. So it shows detailed permissions granted by a cluster role, including all resources and verbs which are allowed. The view cluster role is a built-in read-only popular role for granting read access across namespaces. So this is how the output may look like. So you have view, the name of the cluster role, labels, annotation, creation timestamp, and all the resources. So this has, you can get list watch all these resources using this cluster role. Then list cluster role bindings. So get cluster role bindings. So this will list all cluster role bindings showing which cluster roles are bound to which subjects cluster wide. This is essential for understanding who has cluster level permissions and which service accounts have elevated privileges across the entire cluster. So output may look something like this. You have cluster role bindings, the role which it is attached to. This is cluster role, right? Because cluster role binding gets attached to cluster roles. Then describe a specific cluster role binding. So describe cluster role binding and the name. So this is cluster admin cluster role binding name. This shows detailed information about a cluster role binding, including the cluster role, its references, and all subjects bound to it. The cluster admin binding is critical to understand as it grants super user access across the entire cluster. So output may look something like this. You have name, labels, annotation, and the role reference. So it is attached to cluster admin role. So this is the role binding. So this is the role binding, right? Cluster role binding. And who can use this role binding to get this role. So group, we have something called, so this is belong to subjects, this particular group, system masters. Next, create a role with pod read permissions. So now we are creating a role, not the cluster role, but the role, which is namespace specific. So create role, pod reader, what they can do. So this is the actions. They can get, list, and watch, and with which resource object. So it can be pods, it can be deployments, but here in this case it's only pods. So they can get, list, watch on the pod objects, and this is in the whatever default namespace. So we have not specified, so this will go into the default namespace. So creates a role named pod reader in the current namespace that grants read-only access to pods. This is the most basic rbac pattern for granting specific permissions to users or specific accounts within a namespace. And this will be the, so you create like this, and this will be the resulting YAML in the system. So you have role, name, namespace. It has some rules like API group. So pods belong to default. So there is no API group, and what you can do with this particular role. So get, list, watch. Create a role binding to bind role to a user. So create role binding followed by the role binding name. What was the role? And this was created in the previous step. And to which user they can use this role using this role binding. So this creates a role binding that grants the pod reader role permissions to user Jane in the current namespace. This completes the rbac setup by connecting a role to a subject who needs those permissions. And this is the backend resulting role binding. So you have the role binding kind and pod reader binding, default namespace, because we are in the default namespace. And who can access? So user Jane, and role reference. So it has some API group. So in this case, it's rbac authorization creates IO, and the name of the role, and what was the role name, username, and the role binding. Next is to create a role binding for service account. So create role binding followed by the role binding name, pod reader SA binding, and what role? So pod reader, and now we are binding it to service account. So in the default namespace, there must exist a service account with this name, my SA. So this creates a role binding that grants the pod reader role to a service account, my SA, in the default namespace. Service account bindings are critical for pods that need to interact with Kubernetes API. So this is the output, resulting output YAML. So you have kind, role binding, and the name, pod reader SA binding. We didn't specify the namespace, so it will go to the default namespace. And the subject, so in this case, you can see it's slightly different. Kind is service account, and this service account mySA must exist in this default namespace. And what was the role? It was given access to pod reader. Okay, next is to create role with multiple resource permissions. So k create role followed by the role name. Then what actions? Verb, which is get, list, watch, create, update, delete. Then again dash dash resources. So we are saying pods, services and deployments. So using this role you can do all these actions. So this creates a role with full CRUD, create, retrieve, update, delete permissions on multiple resources, pods, services, deployments in the current default namespace. This is the common pattern for developer access in namespace isolated environments. So this is the backend YAML. So you have role. We specified the role name, which is here app developer, right? App developer, and then we have the rules. So this is an array. So first is the pods and services, which belongs to default API group. So there is nothing we specify, and get, list, watch, create, update, delete. Then because deployments belong to apps API group, so it's separate section, and same get, list, watch, create, update and delete. Create a cluster role with node read permissions. So now we are talking about cluster roles. So create cluster role, right? Node reader. Verb is get, list, watch, and resource is nodes, not pods, not deployments or not services. So creates a cluster role that grants read-only access to nodes, which are cluster scope resources. This demonstrates why cluster roles are needed. Some resources like nodes, persistent volumes, and namespaces exist outside of any namespace. So for those we need cluster roles. So this is the backend YAML, cluster role, kind, and the node reader, the name of the cluster role. API groups we don't specify, and resources, nodes, and get, list and watch. Create a cluster role binding to bind cluster role to a user. So k create cluster role binding followed by the name node reader binding, and we have specified the cluster role. In the previous step it was node reader, and we are giving the access to user Jane. So creates a cluster role binding that grants the node reader cluster role permissions to user Jane cluster wide. This allows Jane to list and view nodes from any namespace or context in the cluster. And this is the backend YAML. So cluster role binding, name, subjects, so user Jane, and reference of a role, so cluster role node reader. Create a cluster role binding for service account. So create cluster role binding. So node reader, we are calling it as a service account binding, and we have specified the cluster role, which is node reader service account. So first we have to specify, this is the format for service account, always comes namespace, even if it's default will come, then followed by the colon and the actual name of the service account. So in this case it's monitoring SA. So creates a cluster role binding that grants cluster role permissions to a service account in a specific namespace. This is a common pattern for monitoring tools and operators that need cluster wide read access. So this will be the resulting YAML, cluster role binding, the name what we have specified, and the subject who can assume this particular cluster role binding, like this role through this binding, monitoring SA, and the namespace and the reference to the role. So cluster role node reader. Create a role binding using a cluster role. So create role binding, view binding. So this is the name, role binding, view binding, cluster role view, and user dev user. So these are some more examples. Creates a role binding that references a cluster. So in this case it's slightly, you can see it's a mixture. So we are having a cluster role, but we are creating a role binding. So this is in a namespace. So cluster role binding, but it is referring to a cluster role. This combination is also possible. This creates a role binding that references a cluster role, but only grants permissions within the current namespace. This reuses the built-in view cluster role. So we have built-in cluster role called view to grant read-only access in a single namespace. So in this case, because we have not specified, so it's a default namespace. So this is how it will look like. So view binding. So this is the name of role binding. Role binding, view binding in the default namespace. Who can access is user, dev user, and role reference cluster role view. So in this case, when they do a view, they will only be able to see in the default namespace, not across namespaces. So you can check user permissions with can I. So there is a can I. So after can I, you can ask like what you can do. So you have to specify the verbs. So in this case, create pods. Then you can specify it like as a proxy as Jane. So as Jane, what Jane can do. So this is admins can verify whether they have created successfully all the rbac permissions. So this will test whether user Jane has permission to create pods in the current namespace. And this is essential troubleshooting command for verifying rbac configurations and debugging permissions issues during exams. So because based on whatever we have done, the answer is no. So check service account permissions. So auth can I get pods. So I want to list pods as again, but format is different. System service account default namespace and followed by the actual service account name. So this will test whether a service account, name of the service account, my SA, in the default namespace can get pods. And this is critical for debugging why pods might be failing to access the Kubernetes API with permissions error. So answer is yes. Based on whatever we have done, the answer is yes. So check all permissions for current user. So auth can I and list. So basically, if you are logged in, you can just run this command. This will list all permissions available to the current user in the current namespace. This provides a comprehensive view of what actions you can perform, and this could be useful for understanding what your access levels in exam environments. So we are not specifying as. So this will check for. So this is how it will list out. So you will have resources and then non-resource URLs and verbs. So this first part star.star. So the double wildcard means you can access all resources. First star across all API groups. Second is the second star. This includes everything from pods to deployment, apps to nodes. And then you have non-resource URLs. So this is this part. This grants access to special non-resource API endpoints like /version or health-z. And then the verbs. So this is the last part. The single wildcard here means you can perform all actions on the listed resources. For example, get list, create, delete, patch, etc. So check permissions in specific namespace. So auth can I create deployments followed by the namespace name as you can specify the user also. So this will check the permissions for Jane. So test whether user Jane can create deployments in the production namespace. This shows how to verify cross namespace permissions, which is critical for multi-tenant cluster scenarios. So based on our configuration, it can be, the answer is no. So create service account. So create service account app SA. This creates a service account named app SA in the current namespace. So this is the default namespace. Service accounts are required before creating role bindings for pods and are automatically mounted to pods for API authentication. So this is the simple backend YAML service account and default namespace. Create role with wildcard permissions. So create role, name of the role and dash verb. So if we say star, everything, resource, star, everything. So this creates a role with full admin permissions on all resources within the current default namespace. Use with caution. This grants complete control over namespace resources, typically only for namespace admin or administrators. So this is how the backend YAML will look like: role, name, and everything. Create cluster role with resource names. So we are creating now cluster role, right? Cluster role pod deleter. Name of the cluster role. Delete, verb is delete, delete pods, and resource also you can specify, like this pod's name, nginx pod, test pod. So this creates a cluster role that can only delete specific named pods, and this demonstrates fine-grained rbac control by restricting actions to specific resource instances rather than all resources of a type. So this is the backend YAML cluster role. Name of the cluster role, API groups, because it's pod, so we don't specify, but we can specify resource names like this. Resources are pods, these two, and what you can do, delete. Create role with sub resource permissions. So K, create role. Name of the role is pod exec. Verb is create. So this is sub resource. So dash dash resource pods, but inside pods, what you can do? So we are saying exec. So basically you SH into pods. So creates a role that grants permissions to execute commands in pods without giving full pod management rights. This is critical for debugging access where users need to exec into pods but should not modify them. So this is how it looks like, role pod exec in the default namespace because we haven't specified. And what you can do, resources pods slash exec, execute inside command inside pods. Get YAML of existing role. So straightforward, K get role, name of the role, and O dash O for output and YAML. So outputs the YAML definition of an existing role, essential for understanding role structure, copying permissions to other namespaces, or creating similar roles with modification during exam. So you can just dash output YAML and space, and then you can put a angle bracket and redirect to a file and modify it. So this is how the YAML will look like. Role, name, namespace, or other information. Rules, so API groups, pods, get list watch. So this is the existing pod reader role. Create role binding for group. K create role binding. Name of the role binding, so dev group binding, and this is for this particular role. So app developer dash dash group developer. So we are still in the namespace because this is role binding and we are specifying a group. So creates a role binding that grants role permissions to an entire group rather than individual users, and essential for managing team permissions efficiently in enterprise environments and LDAP or Active Directory integrated clusters. So this is the backend YAML role binding. Name of the binding in the default namespace. Group is the developers and what role they can assume. App developer. So delete role, K delete role followed by the role name. Deletes a role from the current namespace. So this is namespaced resource. So any role bindings referencing this role will become ineffective immediately, revoking permissions from all bound subjects. So you will get a message saying that it's deleted. Next is to delete role binding. So K delete role binding followed by the role binding name. So this is also in the default namespace because we haven't specified -n. So deletes role binding, revoking the associated role permissions from the bound subjects. The role itself remains intact and can be rebound to other users or service accounts. So you'll get a message saying that it is deleted. Delete cluster role. So K delete cluster role and the name. So no namespace. This is cluster wide. Deletes a cluster role from the cluster. All cluster role bindings and role bindings referencing this cluster role will become ineffective, revoking permissions cluster wide. So you'll get a message saying that it was deleted. Delete cluster role binding. So K delete cluster role binding followed by the role binding cluster role binding name. So deletes a cluster role binding, revoking cluster wide permissions from the bound subjects. The cluster role remains available for creating bindings with different subjects. So you will get a message saying that it is deleted. And that's all. Thanks for watching.